How to understand Maxwell's equations simply. Imagine a world where electric charges and magnetic forces dance together, shaping everything around us. That's what Maxwell's equations reveal. They are for simple rules that explain how electric and magnetic fields behave and interact. These rules are the foundation of all modern electrical engineering and electromagnetism. Let's start with the first rule. When you have electric charges, they create an electric field around them. Think of it like invisible lines spreading out from a positive charge and ending at a negative charge. This is called Gauss's law for electricity. It tells us that the total electric flux out of a closed surface depends on the amount of charge inside. So, more charge means a stronger electric field. Next, we look at magnetic fields. And like electric charges, magnetic monopoles, or isolated magnetic charges, do not exist. Magnetic fields always form closed loops. Gauss's law for magnetism states that the total magnetic flux through any closed surface is zero. This means magnetic field lines never start or end, they always loop back on themselves. Now, what happens if the magnetic field changes over time? According to Faraday's law of induction, a changing magnetic field creates an electric field that circulates around it. This is how transformers and electric generators work. When the magnetic field varies, it induces an electric current in nearby conductors. The last rule involves electric currents and changing electric fields. Ampere's law, with Maxwell's addition, says that magnetic fields are generated by electric currents and by changing electric fields. Maxwell added the idea of displacement current, which is a changing electric field. This addition allowed the equations to predict electromagnetic waves, like light and radio waves, that can travel through space without a medium. Putting it all together, a changing magnetic field makes an electric field. A changing electric field makes a magnetic field. This cycle keeps going, creating waves that move through space. These waves are the basis for wireless communication, radio, and many other technologies. Mathematically, these rules can be written in simple forms that describe how fields behave at a point or over a surface. For electrical engineers, understanding these equations helps in designing antennas, circuits, and systems that send and receive signals. Practically, Maxwell's equations explain how antennas transmit radio waves, how transformers transfer energy, and how signals travel through cables and air. They help us understand the behavior of microwaves and radio frequency devices. In essence, Maxwell's equations connect electric charges, currents, and fields into one unified picture. They show how electric energy can turn into magnetic energy and vice versa. They also explain how light and radio waves are created and travel through space. These rules are the backbone of all modern electrical engineering and electromagnetism.